In this recording, we are going to talk about finding the volume of a square-based pyramid and the volume of a cone. So we could take a square-based pyramid and we could place it inside of a rectangular prism as long as the length and the width are the same. So let's say the length and the width are both b. So the pyramid would go from the bottom of the rectangular prism up to meet at a point like this. So hopefully trying to draw 3 dimensions here, even though I'm working in a flat space that's 2 dimensions, hopefully this makes sense to you. And you can see that the pyramid fits inside of the prism. Now the volume of the prism is definitely bigger. There's some empty space left over. This pyramid only fills part of it, a fraction of it. You're going to do an activity. You're going to try to build a pyramid with Lego, and you're going to compare the volume of your pyramid that you built with the volume that you would get if you were making a prism. So to demonstrate that, you could get out some Lego if you still have some, or you could use this website, Build with Chrome. I have the link for you. Or there's also another link I have for you. It's a building Lego kind of app software that you can download. So you could either use this online Lego, and it's going to be very easy for you, so you can just open it up in your browser, or you can download. So if I want to make a pyramid, I can add the base of the pyramid. I'm trying to make it a square, remember, so I need to count. We're going to say that this piece here, this one piece, we're going to say that that's 1 unit cubed, and that something like this 4 piece would be 4 units cubed. It's not exactly perfect cube, but that's what we're going to say, and that's what we're going to do. So right now we have 1, 2, 3, 4, 5, 6, and 8, so I need one more. And I can continue to build all the way up. It's a little bit tricky. You might need to change your view around. You might need to right-click and delete some that go in the wrong place. But if you keep building, you will eventually get basically a pyramid shape. So I've already made one, and I have it right over here. Okay, so what can we see about this pyramid shape? It's not exactly a perfect pyramid. A pyramid is not supposed to, for the volume formula, it's not supposed to have these bumpy, steppy sides. It's supposed to have a smooth side. So if we try to smooth this out, how are we going to smooth it out? If I start at this point and go up, then I actually have a lot of extra volume. So if I was trying to calculate the volume of this pyramid, and I said it's 1, 2, 3, 4, 5, 6, 7, 7 by 7 for the base, then I have a lot of extra bumps. Well, maybe I can say it's 8 by 8. If it was going 8 by 8, then it would be more like this. And really, what I've made with Lego, the volume's a little bit smaller than this. So it's kind of hard to get an exact volume. We're not going to get an exact volume here, but the bigger you make your pyramid, the more these little bumps are just going to be little bumps. It's not going to matter as much. And you can try doing a few different variations to make up for the space. So one thing that I tried to do to make it a more smooth side, I tried using these pieces. And I tried going like this. And if I do it closer to the edge. I can also rotate the blocks around. I can do it like this, make this whole side nice and smooth. And then I can start building up the next side. And this is looking pretty nice, right? It's looking pretty smooth, much better than that bumpy, steppy pyramid. Looked like it was made out of limestone in the Egyptian desert or something. But the tricky part is when I go to do the other side. Whoops. Sometimes it drops down extra pieces, places you don't expect. When I go to do this side, okay, I'm having a tough time, so I'm going to rotate it a little bit. There we go. So the side lengths work out pretty well. But the corners, I can't get perfect. Maybe you can come up with a strategy for that. Maybe you can use just a small piece like this. And when you calculate, you can keep track of, well, this piece really is like half or a quarter. The corner would be like a corner of a unit cubed, and that other spot here would be half of a unit cubed. So if you use this smaller, flatter piece and consider it to be a quarter of a unit cubed, that could help you with the corner pieces anywhere where it doesn't match up. And then when you build your Lego, you can figure out the volume better. When you want to calculate your volume, you're really just counting the pieces. So if I had tried to make a pyramid that was very small, it'll be easier for me to demonstrate counting it. So for this little tiny attempt at a pyramid, it's 3 by 3 on the bottom, so the bottom has 9 pieces, then it has one more piece. So this construction is 10 units cubed. What would you consider the base to be? Well, it's really up to you. You could either consider the base to be 3, and when you're trying to figure out the formula, it would be 3 by 3, or if you know that the pyramid would be more of a triangle, okay, since you know that the pyramid would have a little bit more of a triangle shape, you could decide that the base is actually a little bit bigger. Maybe instead of 3 by 3, maybe 4 by 4 for the base. And then the height here looks like it's 2. And that could be your pyramid. Okay? Sounds a little tricky, but you have a table to fill out. You can build some different pyramids, count it up, see what values you get. There is going to be a relationship between the volume of the rectangular prism and the volume of the pyramid that fits inside. It's a fraction of it. So the more precise you can build a pyramid at a Lego, the better you can estimate the volume and see what that relationship is. Similarly, with this cylinder, we could draw a cone and put it inside of the cylinder. So this cone fits inside the cylinder. That means that the volume of the cone is going to somehow be related to the volume of the cylinder. It's going to be some fraction of it. You have a GeoGebra activity to do for exploring the difference between the volume, well, the ratio between the volume of a cone and a cylinder.